Okay, welcome to a video on solving systems of linear inequalities. The goals will be to graph systems of inequalities and then to find the maximum or minimum value of a function defined for a polygonal set. This video assumes that you have experienced graphing inequalities and specifically linear inequalities. So let's begin. Our first example will be to solve the system of inequalities by graphing, where we have x is greater than or equal to 2, y is less than or equal to 4, and x minus y is less than or equal to 3. Then we will move on to name the coordinates of the vertices of the polygonal convex set. So let's begin by graphing x is greater than or equal to 2. What does that look like? Well, here we go. That's the vertical line going through where x is 2. And then shaded to represent the solutions are to the right of that, where the x values are greater than 2. And it is a solid line because x is greater than or equal to 2. Now we'll move on and graph on the same set of axes, y is less than or equal to 4. And here we are, that's where y is 4. It's a solid line because it's less than or equal to, and then it's shaded below because that's where the y values are less than 4. Finally, let's graph the line and the solution set for x minus y is less than or equal to 3. Here we go. So that has a y-intercept at -3, a x-intercept at +3. It is a solid line because it is less than or equal to. And then when I test the point 0, 0 in my inequality, that works as a solution, so I shade that side of the inequality. Now, what I notice is we have a commonly shaded region, and let me go in and highlight that. The commonly shaded region is right here, this triangular looking area, okay? This is the common solution set. It is a convex set and it is polygonal. All right, so this is my solution set, and I like to always go back and shade that in to make sure it's really nice and clear where that is. And what it asks us to do also is to name the vertices, and those would be the intersection points for it. Okay, so my vertices of the polygonal convex set are at 2, 4, at, let's see, 4, 5, 6, 7, 4, and then at 2, -1. Those are my solutions for this. I've been asked to find the vertices. Okay? Let's move on. The next one is asking us to find the minimum and maximum values of this given function, f of x and y is equal to 2x plus y, for the polygonal convex set determined by the system of inequalities. This relates to a topic called linear programming. Very close to it, actually. And we begin by graphing all of these, what we will later on call constraints, all these other inequalities. So I've gone ahead of time and graphed all of those, yet I haven't clearly identified the common solution set. So let's go ahead and do that. It's an interesting commonly shaded region. All right, so I'll go in yellow and do that. Again, it is a polygonal set of common solutions here. All right. That's my solution set. And now the next step is to go through and identify the vertices again. All right, so I've got -2, 1. I've got -2, 10. Notice I counted by 2's on each of the axes. I've got 5, 3. And I've got, let's see, what is that? 3, 1. So I've got 1, 2, 3, 4 points, 4 vertices. Now, in reality, I should test every one of the points inside my common solution set in this equation, this function. However, there's a shortcut. And that shortcut has been proven mathematically that if we only need to test each of the vertices. If we have a closed polygonal region, we only need to test each of the vertices. And one of those vertices will give us a maximum value, and one will give a minimum value. So that's the shortcut. We don't have to spend all day plugging in actually an infinite number of points in here. The maximum, minimum value for what we will later call in linear programming the objective function, it will come from one of the vertices being plugged in. So we need to plug each of those into our function and see what happens. I'll do that work off to the side here. All right, so the first one I'll do, I'm going to do this vertice, negative 2, 10. So f of negative 2, 10, that'll be 2 times negative 2 plus 10. So that comes out as negative 4 plus 10, which is 6. Okay? I'll move on to my next one. I'm going to go clockwise here, just to stay organized. 5, 3. So f of 5, 3, that gives me 2 times 5 plus 3. So that comes out as 13. That's already bigger. Let's do the next one here, 3, 1. So f of 3, 1, that's going to be 2 times 3 plus 1. That comes out as 7. All right? And we have one more to test. That is f of negative 2, 1. And that comes out as 2 times negative 2 plus 1. So that's negative 4 plus 1, which is negative 3. Okay, so right away, my maximum value, max of f of xy, is at, let's see, boom, 5, 3. And it's equal to 13. The minimum of f of xy is at, let's see, minimum value, we've got negative 3, so it's at negative 2, 1, that's where we get it, and is negative 3. There we go. So we have practiced graphing a system of linear inequalities, and then using the vertices of that system have identified a maximum and minimum values of a given function with the constraints provided, these other inequalities. I hope that is helpful. Good luck, have fun, and practice hard.